All right, hi, eighth graders. I'm just going to go through a few more examples of using scientific notation within word problems. So the key thing here is looking for what context of the story tells you if you're adding or subtracting or multiplying or dividing. So here we have a train carries 5.3 times 10 to the fifth pounds of apples. A semi-truck carries 388,000 pounds of apples. What is the total weight of the two vehicles are carrying? So for this one, again, I encourage you to pause or see if you can figure out what type of operation it would be first. But because they're asking about the total weight, you want to take the train's 5 3/10 times 10 to the fifth. Take all of that and add to it the 388,000. That's going to be how we figure out what the total weight of the two vehicles is carrying. So remember, on the calculator, you're always going to put any number in scientific notation in parentheses. So for this one, I'm going to start by saying 5.3, and then we have that times 10 to the n button, which will auto fill in for us, and then we can just put the exponent of 5. I'm going to arrow out of that exponent to close the parentheses. Then again, make sure I have my addition sign. I'm adding to that 388,000. And the nice thing is we don't have to worry about converting it. The calculator will do all of that for us. Now I'm in standard form, so it gave me the answer in standard form. So I'm going to go back. Reminded me I have to make sure that I hit enter and change the highlighting to scientific. Now if I quit and go back, I can arrow up to the problem I just did and redo that, and it'll tell me 9.18 times 10 to the 15th. So 9.18 times 10 to the 15th, and then the measurement unit was pounds, so we're going to say pounds there. It is important to know how to take that answer and convert it into standard form or go back to normal mode in the calculator, depending on which version they want the answer. All right, second one here. The annual expenditure of the U.S. federal government is $4 trillion, and I made a little note down here of what 4 trillion is in scientific notation. If a $1 bill is 1 times 10 to the negative fourth meters thick, how tall would $4 trillion be? So for this one, I want to take this measurement and I'm going to stack it that many times, 4 trillion times. So I have 1 times 10 to the negative fourth, 4 trillion times. So I'm going to multiply in this one. Here's the measurement that we have, the thickness of that $1 bill, and we're going to copy it 4 times 10 to the 12th times. So we're going to do some multiplication with those two. So again, with my calculator, I like to clear my screen. I'm in scientific mode, so I'm looking for an answer in scientific notation. Each number I have to make sure is each number that's in scientific notation. Remember that negative is down here below the 3 next to enter, which is different than subtraction. Then I'm going to arrow out of the exponent so I can close it and then say times and then open a new one, 4 times 10 to the 12th. Okay, arrow out of that, close my parentheses, and I did something wrong here. Let's go back and see what I did. I have 2 multiplication signs in there. So if I hit clear when there's a syntax error, remember that means that the user error, I did something wrong. It's showing me right there I have 2 multiplication signs. So I can just delete one of them. And there I got 4 times 10 to the 8th. So that would be 4 times 10 to the 8th, and I believe that is meters. Right, if you take $4 trillion and stack it as $1 bills, it's going to be really tall, even though those dollar bills are very tiny and skinny. All right, so light travels 1.5 times 10 to the 11th meters from the sun to the earth at a speed of 3 times 10 to the 8th meters per second. How long does it take light to get from the sun to earth? So in this one, this is similar to one we did last week where we talked about if I have a certain distance that I'm traveling. All right, so let me switch my color so you can see my writing here. The distance divided by your speed would tell you how much time it would take to travel that value. So like if I'm driving 250 miles and I'm going 50 miles an hour, right, if I take simpler numbers here, we can figure out that it's going to take me 5 hours to get there because 250 miles going 50 miles per hour means it's going to take me 5 hours to get there. So in this question, so if I go back to the numbers they're actually using here, The distance that the light is traveling from the sun to Earth, so we can feel it on our faces, is 1.5 times 10 to the 11th. And that speed, we're going to divide by the speed of 3 times 10 to the 8th meters per second. So we can figure out how many seconds does it take, right? How long? Well, they're talking about seconds, so our answer will be in seconds. And notice when I'm writing this, I didn't have to put it in parentheses. I just like to have the habit of always putting it in parentheses. So I remember when I go to the calculator here that I have to put those numbers in parentheses. So again, if I start, the distance we're traveling from the sun to the earth, or that light is, times 10 to the 11th. And again, I'm going to arrow out of that exponent to close the parenthesis. Shouldn't be in the exponent piece. We're going to divide that, so don't forget your division symbol. 3 times 10 to the 8th power. Again, arrow out of that exponent. So I'm going to take those two numbers and divide, and we get 5 times 10 to the second. So 5 times 10 to the second, and that would be seconds. So if you wanted to know what is the value of that number, I can go back to my mode and put it back into normal mode. And then I'm going to quit out of that screen, second mode. I can arrow up to, here's what I typed in, but here's what 5 times 10 to the second is worth. It's worth 500. So it takes 500 seconds for light to get from the sun to Earth. So there's my answer in scientific. In standard form, whoops, that looks like an S, not a 5. In standard form, that would be 500 seconds. All right, then we got one more here for you, and then you're going to have a bunch of questions to try. The diameter of a human hair is 9 times 10 to the negative 5th meter, so it's really, really tiny, right? While the diameter of a spider's silk is 3 times 10 to the negative 6 meters. So again, very, very skinny, thin. What is the difference between the two? So in this one, we're looking for the difference between, and if you remember correctly or took a guess before I'm going to say it, difference is what we call the answer after we subtract. So we want to subtract the two values here. So the human hair, I'm going to take that number and put in parentheses, minus 3 times 10 to the negative 6. Now, how did I know to put that one first? Why is the human hair first? Well, if I look at the order of magnitudes, -5 is going to be further to the right on a number line than -6, right? If I drew out a number line here, so here's, oops, here's 0, here's -1, here's -2, -3, -4, -5, and here's -6. -5 is farther to the right than -6, so when I'm subtracting, I'm starting with that bigger value. So now that I've already put my parentheses within the question, difference meant what I call the answer after I subtract. So I want to subtract the human hair minus the spider silk. So human hair is thicker than the spider silk, but I'm going to, in parentheses, put 9 times 10 to the negative 5th. Arrow out of that exponent. Then I'm going to subtract. Don't forget the actual operation in there. And then 3 times 10 to the negative 6th. Arrow out of that exponent. And we get our answer. And I'm in standard form again because I forgot to switch it. So I'm going to go back to my mode and switch my mode. It's highlighted on normal, but I'm blinking on scientific. So if I hit enter, it switched it. And now if I go back and try that question one more time here with subtraction in scientific notation, 8.7 times 10 to the negative 5th. And I can say my label would be meters because both of those were in the unit of measure called meters. All right, so that is it for my questions. You now have an assignment posted in Google Classroom. It is labeled U1.11. It's using Desmos. It starts with questions that will require the yellow calculators and then works into questions where you just identify the operation and how it's set up and then just solving some questions. So make sure you're working on that. Should have plenty of time to get that finished before you go. Anything that is not completed will be homework today. Thank you, and make sure you make good choices to behave.